Good day, learners! Welcome to General Mathematics Learn by Video series. This is brought to you by QuexBook Smart Mobile Learning and PerkDC LearnHub. I am Engineer Rex Jason Agustin, and this is now our second lecture video on simple and general annuities. In this General Mathematics series for grade 11 senior high school students, we are now on Part 2 Basic Business Mathematics. Again, in this video, we are going to continue discussing simple and general annuities. Please get your pen, paper, and calculator so we can get started. Our targeted most essential learning competency illustrates simple and general annuities. For the topic outline, we only have one, that's general annuity, because this is just a continuation of our previous lecture video. Okay? In line with the MELC, our learning objective for this session is that at the end of the lesson, the learner is able to illustrate general annuity. Okay? We are done illustrating simple annuity in our previous lecture video, so now we are just going to have general annuity. Are you ready? Let's get it on! From the previous lecture, we learned that annuity is a series of uniform payments or fixed amount of money made at equal intervals of time. That can be annually, semi-annually, quarterly, or monthly. There are several ways to classify annuity. Based on interest period and payment interval, annuity can be simple annuity or general annuity. Simple annuity is an annuity in which the number of compounding periods per year coincides with the number of annuity payments per year. In the previous video, we were able to derive the formula F is equal to A times quantity 1 plus I raised to n minus 1 over I, and we were also able to derive the formula P is equal to A times quantity 1 minus 1 plus I raised to negative n over I, where F is the future value of annuity, P is the present value of annuity, A is the annuity or amount of regular payments or deposit, I, that is our interest rate per period, that is equal to R over M, N is equal to number of regular payments or deposits. General annuity is an annuity in which the annuity payments and compounding periods do not coincide. For general annuity, we can use the formulas F is equal to A times quantity 1 plus I raised to n minus 1 over I, and P is equal to A times quantity 1 minus 1 plus I raised to negative n over I. These are the same formulas that we use for simple annuity. However, there is a slight difference. F is equal to future value of annuity, P is equal to present value of annuity, A is equal to annuity or the amount of regular payments or deposits, but now I is the equivalent interest rate per payment interval. Okay? That is, if the payment is done annually, but the interest rate given is compounded quarterly, we still need first to compute for the equivalent interest rate per year because the payment is done annually. Okay? N is still the number of regular payments or deposits. Okay, so note that there is an extra step that occurs in finding I. The given interest rate per period must be converted to equivalent rate per payment interval first. Okay? That is how we solve general annuity problems. Let us show that through examples. Let us have example number 1. Suppose Rafael Asher, a high school student, would like to save 5,000 pesos every year in a fund that gives 10% compounded semi-annually. How much is the amount or future value of his savings after 4 years if the deposits are made every end of the year? This is not a simple annuity problem. As we can see, the deposits are done every year or annually. We have 5,000 pesos every year, but the interest is compounded semi-annually or every 6 months. We have 10% compounded semi-annually. The number of deposits in a year does not coincide with the interest interval. Thus, this is general annuity problem, right? For this problem, we are going to show two solutions. For our solution number 1, we will have to draw a cash flow diagram to better illustrate what is happening to Rafael Asher's saving. At the end of first year, he will deposit 5,000 pesos. At the end of second year, another 5,000 pesos. At the end of third year, he will deposit again another 5,000 pesos. And at the end of fourth year, another 5,000 pesos. Using the compounding interest formula, future value F is equal to principal P times quantity 1 plus R over M raised to MT, we are going to compute for the future value of each deposit. First, let's note that the deposit made at the end of first year is also done at the end of the second semi-annual. In 1 year, we have 2 semi-annuals, right? The deposit made at the end of second year is also done at the end of the fourth semi-annual. The deposit made at the end of third year is also made at the end of the sixth semi-annual. And the deposit made at the end of fourth year is also done at the end of the eighth semi-annual. Okay? This 5,000 pesos deposited at the end of fourth year is just equal to 5,000 pesos at the end of year 4. This 5,000 pesos deposited at the end of third year will have a future value of 5,000 times quantity 1 plus 0.10 over 2 raised to 2 times 1. We just use this formula here. We substituted 5,000 pesos for principal P. Okay? We substituted 0.10 for the nominal rate R. We have here 10% compounded semi-annually. We substituted 2 for frequency of conversions M. For compounded semi-annually, M is equal to 2. And we substituted 1 for T. Okay? From third year to fourth year, that is 1 year interval. Okay? Notice that the exponent 2 times 1 is equal to 2. That refers to the 2 semi-annuals from third year to fourth year. Pressing this in our calculator, we will have 5,512.50. Right? This deposit made at the end of second year will have a future value equal to 5,000 times 1 plus 0.10 over 2 raised to 2 times 2. We substituted 2 for T because from second year to fourth year, that is 2 years interval. The total exponent 2 times 2 is equal to 4. That refers to the 4 semi-annuals between end of second year and end of fourth year. Pressing this in our calculator, we will have 6,077.53, right? And then this 5,000 pesos made at the end of first year has a future value equal to 5,000 times 1 plus 0.10 over 2 raised to 2 times 3. From end of first year to end of fourth year, that is 3 years interval. The total exponent 2 times 3 is equal to 6. That refers to the 6 semi-annuals between end of first year and end of fourth year. Pressing this in our calculator, we should get 6,700.48. Next step, just add all the present values obtained. That is 5,000 pesos. That's what we have here. Plus 5,512.50. That's this one. Plus 6,077.53. Okay, that's this one. Plus 6,700.48 for this one. Okay. Adding this 4, we will get 23,290.51. Therefore, the amount of his savings after 4 years is 23,290.51 pesos. Okay? Let us try again solving this problem, but this time, let's have a different solution. Okay? For our solution number 2, we will still be making use of this cash flow diagram, and we will use this as our guide. Okay? We can actually solve this problem if we use the derived formula for the future value of annuity. F is equal to A times quantity 1 plus I raised to n minus 1 over I, where A is the annuity or amount of regular payments or deposits, I is the equivalent interest rate per payment interval, take note of this one, and n is the number of payments or deposits. In this problem, we have the given A is equal to 5,000 pesos and n is equal to 4. That's 5,000 pesos every year for 4 years. Okay? We don't have problem with this given. However, for I, we will not be using 0.10 over 2, which is equal to 0.05. Okay, we will not be using this one, even though we have here 10% compounded semi-annually. Why not? Because this is for semi-annual compounding. Note that the deposit is done every year or annually. This is the crucial part. We need to compute for the equivalent annual interest. Okay, I is the equivalent interest rate per payment interval. Okay, the payments or deposits are done every year, so we need to compute for the equivalent annual interest. Okay, for us to do that, we should recall that for equivalent rates, their effective rate of interest must be equal. Effective rate of interest is equal to 1 plus I raised to m minus 1. Can you still recall this formula? I hope you do. If not, if you already forgot about this, you might want to check our last lecture video on simple and compound interest. Okay? Now, we just have to equate the effective rate of interest annually to the effective rate of interest semi-annually. Okay? Substituting the formula, we have here on the left side, 1 plus I raised to m minus 1. We have the subscript A to indicate that it's for annual computation. And on the right side, we have 1 plus I raised to m minus 1. We have the subscript SA to indicate that it is for semi-annual compounding. We can actually cancel out minus 1 here on the left side and minus 1 on the right side. And then substituting the values, we have 1 plus I sub A. We are going to compute for this one, raised to 1. M is equal to 1 for annual compounding. That is equal to 1 plus 0.10 over 2 raised to 2. That's for 10% compounded semi-annually. Okay? And then simplifying, we will get 1 plus I sub A is equal to 1.1025. 1 plus 0.10 over 2 raised to 2 is equal to 1.1025. Then transposing 1 from left side to the right side, we will get I sub A is equal to 0.1025. Okay? Now that we know that the equivalent annual interest rate is 0.1025, that is equivalent to 10% compounded semi-annually, the next thing to do is to substitute the values to this formula. F is equal to A times quantity 1 plus I raised to n minus 1 over I. We will have F is equal to 5,000 times quantity 1 plus 0.1025 raised to 4 minus 1 over 0.1025. Pressing this in our calculator, we will have 23,290.51. This is the same answer that we have with our solution number 1, right? Therefore, the amount of his savings after 4 years is 23,290.51. Let us now go to example number 2. How much money should you invest today in an account that earns 5% compounded semi-annually in order to withdraw 10,000 pesos every year for 4 years? This is another general annuity problem. We can see that the 10,000 pesos withdrawal is done every year or annually, but the interest is compounded semi-annually. That is 5% compounded semi-annually. The withdrawal does not coincide with the interest interval. This is a general annuity problem. Okay? For this example number 2, we are going to show two solutions. For solution number 1, we are going to draw a cash flow diagram. At the end of first year, 10,000 pesos withdrawal is made. That is also at the end of second semi-annual. At the end of second year or at the end of fourth semi-annual, another 10,000 pesos withdrawal is made. Another 10,000 pesos withdrawal will be made at the end of third year or at the end of sixth semi-annual. And at the end of fourth year or at the end of eighth semi-annual, another 10,000 pesos withdrawal is made. Okay? Using the compounding interest formula, P is equal to F over 1 plus R over M raised to MT, we are going to compute for the present value of each withdrawal. Okay? This 10,000 pesos at the end of year 1 has a present value equal to 10,000 over 1 plus 0.05 over 2 raised to 2 times 1. We just substituted 0.05, okay, that's 5%, for our nominal rate R. We substituted 2, okay, for our frequency conversion M. For compounded semi-annually, M is equal to 2. And we substituted T is equal to 1 because this is done at the end of first year. Okay? Using our calculators, we should be able to compute 9,518.144. This 10,000 pesos at the end of second year has a present value equal to 10,000 over 1 plus 0.05 over 2 raised to 2 times 2. Okay, T is equal to 2 because this is done at the end of second year. Using your calculator, you should get 9,059.506. This 10,000 pesos at the end of third year has a present value equal to 10,000 over 1 plus 0.05 over 2 raised to 2 times 3. Okay, this is done at the end of third year. Using your calculator, you should get the value 8,622.969. And then this 10,000 pesos at the end of fourth year has a present value equal to 10,000 over 1 plus 0.05 over 2 raised to 2 times 4. It's done at the end of fourth year. Okay, this is equal to 8,207.466. Next step, Just add all the present values obtained, 9,518.144 plus 9,059.506 plus 8,622.969 plus 8,207.466. That is equal to 35,408.085. Okay? So the amount that you should invest today is 35,000 pesos and 408.085. Okay? That's 35,408.085. Okay, that's the amount of investment you need so that you can withdraw 10,000 pesos every year for 4 years. Okay? For solution number 2, let's make use of this cash flow diagram as our guide. We can actually solve for this problem using the derived formula for the present value of annuity. P is equal to A times quantity 1 minus 1 plus I raised to negative n over I, where A is the annuity or amount of regular payments or deposits, I is the equivalent interest rate per payment interval, and N is the number of payments or deposits. Okay? For our given, we have A, 10,000 pesos. That's the amount of the yearly withdrawal. And N is equal to 4. Number of payments or deposits, or in this case, withdrawals. We have 4 withdrawals. Okay? That's 10,000 pesos each year for 4 years. For I, we will not use 0.05 over 2, even though we have here 5% compounded semi-annually. Okay, we're not going to use 0.05 over 2 or 0.025 because that is for semi-annual compounding. The withdrawal is done every year. So we need first to compute for the equivalent interest rate per year. How do we do that? Let's again recall that for equivalent rates, their effective rate of interest must be equal. Effective rate of interest is equal to 1 plus I raised to m minus 1. Okay? So we are just going to equate the effective rate of interest for annually and the effective rate of interest for semi-annual. Okay? On the left side of the equation, we have 1 plus interest rate for annual compounding raised to m for annual compounding minus 1 equals 1 plus interest rate for semi-annual compounding raised to m for semi-annual compounding minus 1. We can cancel minus 1 on the left side and minus 1 on the right side. And substituting, we have 1 plus, we are going to compute for the equivalent interest rate per year or annually raised to 1. M is equal to 1 for annual compounding. That is equal to 1 plus 0.05 over 2. Okay, this is for 5% compounded semi-annually. Okay, M is equal to 2 for semi-annual compounding raised to 2. Simplifying, that would be 1 plus the equivalent interest rate annually. That is equal to 1.050625. Okay, 1.050625 is equal to 1 plus 0.05 over 2 raised to 2. Okay? Transposing 1 from the left side to the right side of the equation, we will get the equivalent interest rate per year or annually is equal to 0.050625. Okay? Now that we know the equivalent interest rate per payment interval, that is equivalent interest rate per year or annually is equal to 0.050625. Okay, this is equivalent to 5% compounded semi-annually. The only thing left to do is to substitute the values. Substitute the values to this equation. P is equal to A times quantity 1 minus 1 plus I raised to negative n over I. That will be P is equal to 10,000 times quantity 1 minus 1 plus 0.050625 raised to negative 4 over 0.050625. Using our calculator, we will be able to compute 35,408.085. This is the same answer that we have from solution number 1, right? Therefore, the amount that you should invest today in order to have 10,000 pesos withdrawal every year for 4 years is 35,408.085. Alright? Before I end, just want to give a tip. When solving for equivalent rate, use at least 6 decimal places or the exact value. Why? Because if you use fewer decimal places, the tendency is that there is going to be a discrepancy with our answer. Though most of the time, those discrepancies can be ignored, it is still better if we are accurate with our answers. Okay? Now, let us check what have we learned. In this video, we were able to illustrate general annuity, right? Very good. In our next video, we are going to have simple and general annuities part 3. In that video, we are going to distinguish between simple and general annuities. For more related practice problems, you may use our QuexBook General Mathematics app available from Google Play Store and answer Chapter 4.